Yeah, I was doing my work, right? And I think now for the upcoming one, which is November 3rd, I think there's already like 300 something registered attendees. So it is right now the most popular working group in the ROS community. It is certainly capturing lots of interest across academia and industry. So super excited.
I could sort of feel that there was a trend within Roscon about that, but I'm a bit ignorant into what the actual applications, like examples that we could do in like tangible ideas, like how can I achieve with this? How can this help me, let's say, in a drone?
Correct. So for the particular case of a drone, there's various tasks you may want to accelerate in terms of computations, faster computations or reducing the power consumption. The first one is probably the lowest hanging fruit, which is the one that I demonstrated in my talk, is perception.
Mm-hmm.
So the perception stack often takes a huge chunk of your computing systems while you're doing any sort of like autonomous drone task. So if you can somehow limit the amount of CPU you are consuming with those tasks, and you can push it or offload it into an accelerator, then those CPU cycles can be used for higher level tasks, such as better planning, better navigation, or even more complex tasks. So again, perception is a very, very well-defined use case. Accelerated navigation is also a pretty easy to understand one. Right now, often the case when you are navigating around a place, every time that the environment changes, you need to recompute often your plan. And that recomputation takes some time depending on your parameters, your algorithms, the environment, and the sensors you process. This recomputation can actually be accelerated in navigation. And similarly also in the case of manipulation. I know it's not so common yet to do manipulation on drones, but there are some ongoing projects actually that are attaching manipulators into the drone. And so right now with MoveIt, for example, which is the default manipulation stack in ROS 2, the most popular one at least, every time with a decent modern computer, every time something changes in your like manipulation plan, when you are planning a grasp, you need to recompute the grasp, and this can take up to 2 seconds. Now if I'm moving this cup like this, do you think that if it takes 2 seconds for you to plan, will you ever grasp it?
No, I don't think you're
right?
Be able to.
So that is the real power of hardware acceleration, that you do have a chance to compute really fast what you want to grasp and then execute. And then it's up to your actuators. Maybe they are not fast enough and they will still...
But that's a different problem.
Exactly.
Yeah. Okay, that's great. And I saw you also run a survey within the conference. I'm like, okay, what is the most important thing to you when doing hardware acceleration?
Yep.
And the response was real time, right?
Correct. Yeah. So, and again, that confirmed kind of like the hypothesis we had quite a while ago, and the one we've been using to drive our work, which is that people really focus in the robotics domain in making sure that their systems respond in the well-defined timings they do specify, so that actions make sense. And on that, we are increasingly being more and more surprised.
Master?
Muchas gracias, sí. Muy amable. How essentially people keep that at the top of their list. The second one is determinism, like have things happening exactly in the same order, and essentially every single time. I don't know if surprisingly or unsurprisingly, we do see... Muchas gracias. We do see that people do not seem to care so much, at least in the ROS community, about power consumption. It was actually the one last cited, and that is, to me, a bit surprising, because mobile robots are all kind of like limited by
their operation time.
Exactly. And so I think that in the drone space, I think that is something we care a lot about, because we are used to having like bulky systems with 15-minute, of autonomy. Maybe if you like to optimize your system appropriately, you get to 30 minutes.
You're lucky if you can get 30.
Right. But way beyond that typically requires you to move beyond electrical drones and go into some alternative source. I've seen some of those. We've built some of those. You could significantly lower the computing power consumption by means of hardware acceleration as well. So hopefully over time, people will also start paying attention to this. I think the drone space is a bit interesting because still I think the major source of energy consumption are still the rotors, the motors themselves, but there are ways also to try to reduce that. I think UPenn showed a fantastic case study. I don't know if you had the chance to watch that talk, but they spoke about how they are rotating, they are using big propellers, and they are rotating slower, so that essentially they can reduce the power consumption there. So pretty interesting.
Who gave that talk, Fernando?
Fernando.
Okay.
Sí.
Yeah. Okay.
Yeah, and he did an amazing job. I made sure to speak with him because their lab is actually working on super interesting stuff that does require and can only be possible if you use hardware acceleration. They do have some kind of like needs wherein the autopilot itself needs to actually evolve.
Yes.
And turn into something that exposes information at the IMU level, gyroscopes, magnetometers, and so on and so forth, outside of the current autopilot black box that often the case we use to build drones, and into the ROS world, so that more complex behaviors can be enabled.
That's interesting, because right now we've been treating like the autopilot more like a black box.
Right.
And it's been working so far, but how do we get that out, and how do we extend it? And it's a limiting factor at some point, because you got the flight controller, you got the data there, but if you want to change anything, you have to actually go and change that, and then you're limited by the capacity of that flight controller, when you can actually have a companion computer that is much more powerful to do those computations.